Hello, my name is Stephen Payne. I'm the CSER Project Officer for Western Australia. I work with the CSER Project Group at the University of Adelaide. And in this video, I'm going to talk about the CSER programs, online courses and other resources that we have, and talk a bit about the digital technologies and computational thinking and how that applies from pre-primary to Year 2 classrooms. You can pause here and send me an email or send me a tweet or visit our website and you'll find information about all the different programs that we run. Our most popular are the MOOCs. These are online courses and I'm going to talk a little bit about those as we go through. We also have kits that we can lend out to schools. We provide professional learning face-to-face, and we have a whole range of other resources to support you in teaching and learning with the digital technologies subject. So we're going to look at the CSER project. We're going to look at the digital technologies curriculum and a few ideas for pre-primary to 2, and then some great resources where you can go and find further information. So the program actually started back in 2014 with support from Google. There was an online course set up to support teachers learn about the digital technologies subject area. Over 10,000 teachers have now participated since then, and the program was actually expanded last year in 2016 to include project officers in each state and territory in Australia. We also have kits that we can lend out to schools, and we've created a range of resources that you can use to deliver your own professional learning in a staff meeting, professional learning day or teach meet. So it really is an amazing online professional learning opportunity. We have a whole lot of content with sample activities, practical ideas that tie into subjects that you have been teaching for a while. You can learn online at your own pace, and what's really important is there's a network of learners. There are thousands of teachers across Australia who are teaching digital technologies for the first time. They're sharing great resources that they found, photos and videos of student work, and it's a really great community to share and learn. And a reminder, there's our website. As I mentioned, we have project officers right across Australia. I do this big part of the country here, Western Australia, and we've got colleagues right around the country. There's just a few stats there about enrolment to date, and what's quite interesting, I think, is that 79.9% have not done any computing related PD before. So just like you, these are teachers who are looking at the digital technologies curriculum and wanting support and ideas of how to integrate it or teach it in their own classroom. As you start exploring the digital technologies curriculum, you'll find that there's a large amount you already know, and you already do. There are great links with art, English, music, science, and so on. So what we're looking at is how can we adapt what we currently do with some new concepts, some new ideas, some new skills. And how can we work smarter and not harder? And what support can teachers give each other to move through the challenges? What can you do within your own school to support each other? What can you do in your community? And what can you do with connecting with teachers right across Australia? So just a really key thing that I always like to stress with teachers when I speak about this is that the digital technologies curriculum is part of the technologies learning area. It's a subject along with design and technologies that make up the technologies learning area, both in the Australian curriculum but also in the WA curriculum that we use in Western Australia. So all schools will be implementing this by next year and will be reporting on digital technologies and design and technologies from 2018 as well. It's not just a new name for ICT, it's a new curriculum area. This is a really great poster that I've got up above my desk, and I always recommend teachers have it in their staff room or their classroom, just as a really quick reminder of what is the general ICT capability and what is digital technologies and what are the differences. So I really like this this column down the front, down the middle. So for example, if you're using presentation tools, if you're looking at managing files, online communication, we're using ICT to support other learning areas. But if we're actually creating with the ICT, so we are coding or we are designing a user interface, we're looking at algorithms and pattern recognition, then we're actually creating solutions using the ICT, and we're learning about digital technologies and how it works. So a good analogy might be that using the ICT as a general capability is like learning to drive a car. But if you actually find out how the car works and you tinker under the bonnet, that's more like the digital technologies area. We might be making improvements, working out how things work. So on the right hand side here, we've got some examples of ICT in red, and the green is digital technologies. So if we're using presentation software to present findings, so we've researched a project and we put some pictures and videos and we've made a presentation, then that's really using ICT to support your learning about something else. But if we make that interactive, so we have students have to click buttons or answer questions to progress through the presentation, then we're actually creating a solution, and that is using digital technologies. This poster can be downloaded from the Digital Technologies Hub, and I'll put the link at the end of this video. So just a few comments that I think answer some questions about digital technologies. It doesn't replace the use of ICT, as I've just mentioned. Computational thinking is a really important skill that is embedded right across this curriculum area, and we're going to talk a little bit more about that later. Students will learn various programming languages, but in the WA curriculum, the use of actual visual programming languages doesn't really come in until year 3 or 4. 50% of the curriculum can be taught without the use of a computer, and we've referred to these as unplugged activities, and I'll give you some examples of how we can actually introduce the concepts and the skills of the digital technologies curriculum without actually using any digital resources. Integration is quite natural. As you look through the curriculum and the scope and sequence, you'll see that there are lots of things that you do already in English, in science, in maths, and so on. So if you can integrate and make projects that actually involve different areas of the curriculum, it's a much richer experience and more relevant for the students. Whole school planning is essential, and the curriculum is written in year levels. I've just put a picture up. That's a snapshot from the CSER website, which looks after the WA curriculum, and you'll find on this website the descriptions for each year group, how the subject is organised, and some really good ideas on ways of teaching and assessing, and links with the other capabilities and curriculum areas as well. They've also made available a scope and sequence document, so you can see at each year group what students need to know about digital systems, what they need to know about representations of data and digital implementation, and so on. And there's a lot on creating solutions. So rather than just learning how to program, students are learning about how to work with others, how to design a solution, how to refine and implement. So there's a lot of soft skills as well around project management, communication, and collaboration. So what I'm going to do now is just talk through some of the resources we have on our CSER Digital Technologies website. And I'm going to introduce you to the MOOCs that we have and just show you how these are structured and how they can support you and your colleagues. I'm showing you the CSER Foundation to Year 6 course. We've currently got 3 courses. We've got the Foundation to Year 6, and I recommend everyone start at this course. We then have an extension course for primary, which goes into a bit more detail on cross-curricular links and also a bit more in-depth work on visual programming. We've also got a Year 7 and 8 course, and a 9 and 10 course is coming very soon in the middle of 2017. So the way the course is structured is in units, and each unit takes approximately 2 hours to work through. You can see there we've got an introduction to digital technologies, data patterns and play, data representation, digital systems, information systems, algorithms and programming, and visual programming. So actually, programming is just one part of the digital technologies curriculum. There's a lot of stuff on data and about working out how digital systems can be used, and working out the best systems to use and how to be safe online. So there's quite a lot of really good material in the curriculum. We've currently got people from right across Australia. This was taken a couple of months ago. We suggest that people pin themselves to the map. You might find a friend, but just showing that we've got people across Australia and even a few people from overseas as well. So what the MOOC looks like, I've gone into just one of the units on data patterns and play, and you've got lessons within the unit. So here we've got an introduction to computational thinking and data. So we look at from the early years, looking at how we can categorize things, maybe by shape, color, measurement, those sorts of things. So there's always a couple of videos, and the videos are generally just a couple of minutes long, so you haven't got to sit and watch videos all the way through. We then have a couple of example activities that use the concepts from within the curriculum. So this example here is an unplugged activity. So we're using houses. Each student has a house, and they've got colour representations of how many siblings and pets they've got in their house. So we're able to categorize and analyze data using symbols and diagrams, and that's an introduction to data representation. Each unit has a couple of activities, example activities that you can use in your classroom, and there's generally things for different age groups. So if we're measuring height, we might be using technology or not using technology, and there's a couple of different ideas of how we might do that and how that fits into the curriculum. At the end of each unit, you get a task to do. And this is to show your understanding and perhaps share an idea of how you've used digital technologies in the classroom. There's always a couple of options. So here, for example, option 1 is collect and visualize some data from your classroom, your home, online, or from your community. And then share that with the community by taking a photo or a screenshot or putting a link to a website. So that's something that you've done in the classroom. Option 2 says find and share a useful data source that teachers could use as a resource for classroom activities. So all you need to do here is go and find a website or a resource online that has some data that you can see being used in the classroom, and then you just share a link to that. And option 3, if you were hosting a professional learning session with teachers or colleagues, what activity could you do that involves teachers collecting, organising and presenting information? So you don't have to write a whole essay. You can just take a screenshot or a photo or just put a link to another website and say how you think it ties in with data, patterns and play. So you post this in the Google community that I'm going to show you very shortly, and then you just post the link back in here, check your answers, submit your answers, and then that unit is ticked off. So this is the Google community where people are putting their task answers and also sharing really great resources. So I've just logged onto the community here, and I can see a Year 6 class here that are keeping track of the position and results of footy matches. We've got an example here where students are looking about how to behave online appropriately. So they're describing their facial features with mirrors, and they're having a class discussion about how they describe themselves. So there's lots of really great ideas being shared with thousands of teachers across Australia are doing the tasks and sharing and helping each other with ideas as they go through. You can also, on the left hand side here, choose to look at a particular task and see everyone's responses from there. If you want some inspiration or you want some ideas to use in your classroom. So here I've clicked on data, patterns and play, and I can see they've used lollies here. So an unplugged activity, whereas over here they're actually using an online tool that automatically draws column graphs for you. So there's a whole range of really good resources within the community. I've also now gone on and clicked on algorithms and programming, and I can see some examples of flowcharts, some ideas, a link to a YouTube clip. So people are sharing lots of really great ideas, and you can just browse through this and find things that are useful for you. Here's an idea that someone shared about Rosie's Walk, the book by Pat Hutchins. So this teacher, they listened to the story and then they verbally retold it as a whole group. Students were then given pictures from the story and they had to put them in the correct order. Then this could be extended by using robotics. So we could have a map of or a picture of the farm and the barnyard, the flour mill, the haystack, and Rosie's gone missing, and we can control a Bee-bot or another robot to actually go and look at the different areas and see if Rosie's there. And then we've got an example on the right hand side of how we've actually sequenced the story using pictures from the book. And so this is a really simple example of taking something that we already do, and we can build on it and start introducing the language of sequencing and giving control to a robot to actually follow in the path of Rosie. So and that's just one example that I picked up from the community. As I mentioned, we also have a lending library. So we have kits of different technologies. So currently we've got Bee-bots, Ozobots, Spheros and Makey. So any school in Australia can request to borrow a class set of resources, and we'll give you some supporting resources as well as sample lesson plans mapped to different year groups and areas of the curriculum. So if you go to the CSER MOOC's website and click on Lending Library, you can request something for your school. Priority is given to schools in low socioeconomic areas, remote schools, Aboriginal Torres Strait Islander enrolments, and also those people that have engaged with the CSER professional learning either face-to-face or through the online courses. I'm going to mention a little bit about computational thinking, as this is a key concept within the whole of the digital technologies curriculum. So it's really integrating the power of human thinking with the capability of computers. There's a good video by ISTE which I've copied the link in below, and this is one of the final images from it, and it shows that computational thinking is all these things. So problem solving, communication, critical thinking, collaboration, creativity and computing. So computing is just one part of it. It's all about those soft skills of students collaborating, planning, solving a problem, thinking something through logically. That's what computational thinking is about. And then the computing comes in when it helps to solve a problem quicker or in a simpler way than otherwise. These are really the four main types of computational thinking that you'll see in the primary digital technologies curriculum: decomposition, abstraction, pattern recognition, and algorithm design. On the next slide, I've got a poster that one of the CSER Community members made for teachers at her school, actually showing with Lego. So that decomposition is breaking a problem down, looking at patterns, so which parts are the same by size and color, that sort of thing. Abstraction, filtering out the data you need and what you don't need. And algorithm design, which is the step-by-step instructions to achieve the goal. Here's a year one example that I saw in a classroom. The teacher had designed a character and gave verbal and written instructions for the class to draw that character. So draw a circle for the body, add 2 eyes, add a crown, add wings, add 4 legs. The students all ended up with slightly different characters, so they as a class decided how they could make that algorithm clearer. So they edited it, and rather than just draw a circle, draw a big circle, add 2 eyes with eye stalks, and so on. So the idea here is that you are making step-by-step instructions that are clear for someone else to understand. In this case, it's another person, but it may be a robot or it may be a computer when you go on to programming. Here's an activity that I've seen a number of different examples of. So each student creates a monster, and the monster is coded according to attributes of the student. So the body is their favourite shape and colour. The number of eyes is the number of children in their family. The mouth determines whether they're a boy or a girl. How many teeth it has is how old they are. And the strands of hair are the number of letters in the name. So students are able to come up with a monster that's actually encodes within it attributes about the students, and you can have a wall display and students can pick out which is which. So pre-primary to year 2 students should be able to use robotic toys to navigate a map, choose the right system to suit the task at hand, and create simple algorithms. They may be algorithms to control a robot, or they might be algorithms to give instructions to make a recipe or tell a story in a particular way. So lots of different ways that you can introduce computational thinking in pre-primary to year 2 classes. So an algorithm really is a description of the steps and decisions required to solve a problem. So finding the largest number in a list of positive numbers. So on the left there we start the process, we have a question and we can loop around that question, and we stop when we get to the end of it. On the right hand side there is an example of what you might do in the morning. So when the alarm rings, hit the snooze button, wait till it rings again, hit it again, turn off the alarm, get up, have a shower, get dressed, eat breakfast. If the weather's sunny, walk to school, otherwise ride to school with parent. So it introduces the idea of loops and decisions. There are some really good examples of algorithms in the F-6 CSER MOOC, and there are some videos that explain it both from a computer science point of view, but also taking examples from other curriculum areas and everyday life. Here's an example that someone shared in the MOOC. The year 1-2 class took photos of themselves getting ready to start the day. Chair out, lunchbox in fridge, reading folder in the box, pencil case on the desk, etc. And then they made a chart with the most efficient sequence and displayed that in the classroom. And I've just taken from the WA curriculum on the left there. Pre-primary students should be able to generate and record design ideas through describing, drawing, modelling, and or a sequence of written or spoken steps. In year 1, they're developing and communicating design ideas through describing, drawing, modelling, and or a sequence of written or spoken steps. And then that builds into year 2, so they're actually discussing their ideas and beginning with algorithms. So there's lots of use of algorithms right throughout different curriculum areas, and I'm sure you can pause the video and have a little think and a discussion about where you see algorithmic thinking in your day-to-day life. This is a hands-on activity called My Robotic Friends from an organisation called Thinkersmith. And what this activity is about is trying to think about how we can give instructions to someone that are clear and they come with the desired outcome. So it's all about stacking plastic cups or paper cups. So it also helps with oral language, maths, and communication and interpersonal skills as well. So you're given some commands: pick up cup, put down cup, step forward, step backward, turn cup right, turn cup left. And then you have to write out some instructions on how someone can stack the paper cups. And it's a really nice activity that you can do with adults in a professional learning session, but also with students. And depending on the age, you can start introducing, and students do themselves, is coming up with shortcuts. So rather than writing 4 arrows in a row, perhaps we could do 1 arrow and times 4, or put the number in brackets, or whatever we decide to do. And students come up with their own shorthand, which is very much what you would do with programming. You wouldn't write the same thing over and over again. You would use a loop or something like that. Here's another example that I've seen used quite well, the Lego listening game. So the students have a box between them, and one person makes a scene or a model out of Lego, and they give instructions to the other person to follow at the same time. So it really helps with those putting steps in the right order, but also with oral language and again the interpersonal learning. So in this example it's using Lego and Lego bricks, but you could do the same with a grid, and students have to give instructions on which squares are coloured in to make a letter or a shape, and they can follow those instructions and indeed the code that they're giving to each other. Bebot is a really great tool for younger students as well. If you haven't seen the Bebot, just have a look at for some clips on YouTube. You can see some really creative ways where it's used with English, storytelling, maths, direction, and I talked about the idea of linking it to Rosie's walk earlier in this video. There's some really great ideas on Pinterest, and there are some cards that you can print out and actually have a student walk through a path before coding the Bebot or programming the Bebot to actually follow the path. There's also an iPad app as well that really helps introduce students to just particularly left and right, and doing a whole sequence of events in the correct order. There's a whole number of apps that are available, particularly for younger students. Daisy the Dinosaur is a free app that's available on the iPad store. In the slides of this video that you'll be able to download, you can see a really good example of progression from this primary school as well. So there's plenty of apps for this age group, and if you look in the CSER site or you search for digital technologies resources, you'll find a number of apps that are suitable and introduce the idea of algorithms and controlling character. Code.org is a really great resource. So if you go to the website code.org, there's a whole range of plugged and unplugged resources for all ages. I'd certainly start having a look at the Hour of Code. These are short activities around a theme. So if you go to code.org and search for Hour of Code, you can find really great ideas that tie into different topics and films and things that students are interested in, but introduce those key concepts of sequencing things in the correct order, using loops and repetition and branching. Really nice, gentle way to introduce coding in the early years. I use Pinterest all the time, and I like computational thinking is something I search for a lot. I see some really good ideas from right around the world. Computational thinking is in the computer science curriculum in the US and the UK, and there are really great resources that you can find on Pinterest. The Digital Technologies Hub is an amazing resource run by Education Services Australia, and if you go to the teachers section at digitaltechnologieshub.edu.au, search for a topic or search for a robot, type in Sphero or Bebot, and you can find some lesson plans that people have shared that have been tried and tested. There's also some really good resources on here for families. So if you're talking to parents about the digital technologies curriculum, there are some videos and resources that can support this learning at home as well. And similarly for school leaders, there's some really good resources on how you can implement this and the best ways for planning and that sort of thing. This is also where I got that earlier poster which shows the difference between the general ICT capabilities and the digital technologies subject. So have a look at our website, caesarmoocs.adelaide.edu.au. Feel free to tweet me or email me, and if you're in Western Australia, I'm able to come out and give you some support in implementing digital technologies in your curriculum. Thanks for watching.